All right, good morning, folks. So today we're going to be talking about variables. So most of the lecture will be sort of variables and how to use them. At the beginning, we're going to start off just what is a variable, how do you create one in your program, how do you set values to them, that sort of stuff. And then we'll get on more to printing out variables and sort of how to use them in expressions. So today really is one of the fundamental concepts of the entire semester, because we'll be using, of course, variables the entire time in our homework assignments and examples, all of that kind of stuff. Before we get started, I just want to mention a couple of things. I put the information about the tutor sessions on Blackboard. So that's the sort of Monday, Thursday, 6 to 7 tutor sessions that are run by students. So you can sort of drop in, drop out, ask homework questions, that kind of stuff. I also want to mention PA0. So if you still having some issues with that, we can certainly talk about it if we have time after class. Otherwise, my office hours are 11 to noon, so right after the class ends. Hopefully for PA1 that I'll be giving out this week, we'll have those issues resolved. But for now, PA0, we're going to sort of keep that the same, and then I'll just sort of help people out. And potentially at the end of class, I can also show how to check on GitHub if it actually did create your repository, just in case. It may not have shown you that it correctly did it, but it actually did. Remember, at any time, you can throw something in the chat. You can unmute and ask a question, anything like that. So I have a second monitor that I'm monitoring all of that information on. Okay, so let's get started. So some of the fundamental concepts of variables are what I want to start with. And just variables themselves are really the first sort of overarching concept in programming. It's how we store information about what's happening in our program. And if you've been taking algebra classes and calculus classes, you're of course going to recognize that name, because oftentimes that's what you call, say, an unknown a value in a algebra problem or a calculus problem. But variables in programming do work a little bit differently. So don't sort of think of it as an unknown in an equation. Just think of it as a value that will be sort of persistent throughout your program and that you'll be able to change. So I guess the first question when it comes to variables, a value that your program contains, where is it stored? It sort of has to be somewhere, and most of the data on your computer is on your hard drives. Whether you've got SSDs or the spinning platter ones, that's where most of the data is stored. But when your program is running, when it's actually executing all of the code that you wrote, the variables themselves are actually just stored in main memory. They're in your RAM. Most of us have somewhere between probably 8 and 16 or 32 gigs of RAM in whatever computer you happen to be using. So whenever you create a variable, you're using up a tiny piece of that RAM. When you're playing things like video games or running, say, a photo editing software or something, potentially you might be using gigabytes of memory to store different values that are needed in whatever programs you're running. So for us, we're never going to come close to using that much data in any of the assignments that we do in this class. But keep in mind, when you see what the memory usage of a program is, that's just the variables. That's the variables that exist within the program. So each one of those variables is stored at a particular memory location. And we talked a little bit about memory last time. You sort of saw some addresses, and I said, oh, this represents maybe 4 bytes located at address 0, and so on. So that's the idea of a variable. It's a certain amount of ones and zeros located at a place in memory. What the ones and zeros are depend on what the variable is. So that's something that we'll get to here in just a second. Every variable also has a name, and it's something that you assign the variable. So you get to choose what the name is going to be, and as you write your program, you use that name to access the variable and to change its value. essentially each variable only holds one value, kind of. So obviously there's going to be some caveats to some of this stuff that we'll get to later on, but for now, for the first few lectures anyway, think about a variable just holding a single value. And over time, as your program runs, the value of that variable can change. You can update it to change different values to represent different things. Think of a position of, say, an object, for example. It might be moving, say, to the right. So maybe the position of that object will be increasing its value, for example. So that's sort of how these sort of programming variables are a little bit different from their algebraic counterparts. Again, typically in algebra, a variable represents maybe an unknown value, like x or y or something like that, and then say you solve for it or something. So programming-wise, they can represent whatever you want them to represent, and then, of course, they change throughout the program. Anytime during your program, anytime during its execution, you can access that variable. So it's not sort of a one-time thing that maybe an algebraic variable would be. I do want to mention one thing here related to sort of using a variable throughout the program. In principle, you can actually use the same variable to represent different things. But it's not really recommended. If you create a variable to represent, like I just mentioned, a position of an object, it should sort of always represent the position of the object throughout your program. You shouldn't have it represent a position at one point and then maybe I don't know, time or something at some other point in your program. That can get real confusing. So when you create a variable, think of it as sort of one purpose that can change throughout the program. Now I said all the variables needed names. Different programming languages have different requirements for the names of variables and different restrictions. Since we're using Java, that's what we're going to talk about. But if you use different languages in the future, or if you have used different languages in the past, you're going to want to make sure that you remember what these naming conventions are and the requirements that go along with the particular language. So for Java, you have to start with a letter or an underscore. Typically, we're going to start our variable names with letters. Convention-wise, underscores are sort of used in certain situations. But for us, we're going to typically use letters. It can be upper or lowercase. Typically, you'll see me using lowercase for the start of a variable name. They can only contain letters, numbers, and underscores. So numbers sort of comes in here as it can contain a number, it just can't start with a number. And in Java, they are case sensitive. So if you have some uppercase letters in the variable name, and you have the same name with some lowercase letters, they're going to mean different things. So you want to be consistent with how you use case in your variable names. Not all languages are that way. Things like case sensitivity doesn't exist everywhere, but for Java and for most C-like languages, it does. So here's a few good examples. So we have count. That works fine. It's all letters, all lowercase. It works just fine. Something like X, it's not very descriptive, but it is an example of a perfectly fine name. We have a couple here with underscores, and in this case, one of them has a number. These are perfectly fine. Just a number, so like 42, that's not going to work. That Java would actually read that, of course, as a number. So that's not going to work as a variable name. And any sort of special characters here, like a hash or a plus sign or an exclamation point, those are not going to work for names either. So we'll sort of follow along, of course, with the good examples. I have some style notes coming up in just a second about how we're going to typically name our variables and how you will see me name my variables when I do examples. So if we have a name, the other part of creating variables is the declaration. We have to tell Java this variable exists and this is its name. So we give it a name, we have to declare it, and there's one extra piece for a variable declaration. That's the type. We need to give a type to the variable. If you've used languages like, say, Python or JavaScript in the past, you didn't really have to worry about this, and there's various reasons for that in how the languages are compiled and stuff. But for Java, we have to have a type. So this is something that you'll have to get used to, especially if you've never done it before. So I'm going to show you a few types that we'll use throughout the semester. The first one is an int. And this is actually how you declare an int. You say int, lowercase int. This is an integer. It's a whole number. So whenever you hear me say int or integer, that just means it's a whole number. There's no fractional component at all. Ints can be positive or negative. A double is a number with a fractional component, so like 3.5. That would be a double. A Boolean is just a true or a false value. And then we have char. It's just a single character, an A or a C or an exclamation point. Now, I'll show you how to create all of these in just a second, but these are the most common ones, and these are probably what you'll see most of the time in your assignments and any of the examples that I do. So I have a question related to this type stuff, and I want you to think back a little bit to the memory stuff that we talked about at the beginning of this lecture and when we talked about how memory was sort of laid out last lecture. Why do you think we need to specify the type? If you want to throw something in chat, you can do that. You can unmute, but I want to hear some of your ideas. Why do we need to specify the type? And there's more than one answer to this. What do you think?
Can I use my mic, Professor?
Sure, go ahead.
Well, I know that if you use an int and you put a double number, that it won't print out the decimal afterwards.
Yeah, so there's some conversion stuff that happens. That's related to the amount of memory that's available. And because you're specifying a type, Java knows how it should interact when you use it, say, in an equation or when you try to assign values to it. It tells Java exactly what your intent is, and that was certainly what you were getting at. If you take an int, or you say you take a double, and you try to sort of put some other value, an int or a char or a Boolean, say when you do a declaration, there might be an error, or it might chop off part of a decimal or all of the decimal going from, say, a double to an int. So it's these sorts of ideas that you have to tell Java how to use that number or that character or that Boolean. Memory-wise, they take up different amounts of space. So a regular int is going to take up 4 bytes, whereas a double is going to take up 8 bytes. So that has implications in that exact thing that you mentioned. With a double, you have a bunch of decimal place stuff afterwards. So you have to store those values somehow, where an int does not. So it has memory implications as well. Things like a Boolean is only 1 byte. A char, typically 1 or 2 bytes. It depends on the language. So all of these sorts of concepts deal with type, just tells Java how to handle those values in memory and when you try to actually use them in your code. So we will be seeing lots of declarations where we say this variable name, whatever you want to call it, x or count or whatever, is an int, or it's a double, or it's a char. So this is the syntax. This is how we actually do it. The type comes first, and then whatever you want to use for the name. Again, we have to follow the naming conventions. But the type's first, then the name, then a semicolon. I mentioned, I think in one of the first lectures, we're going to see semicolons all over the place. They're going to be everywhere. So you don't want to forget them. Eclipse will help you. If you forget a semicolon, it will tell you, hey, you need to put a semicolon here. But it's something you want to get used to. Not all languages have like end line type things like semicolons. So sometimes you will see me make mistakes as well, depending on what languages I've been working with most recently. So sometimes you'll see me forget them as well. It's a very common sort of mistake to make, is to forget semicolons or other sort of small syntactic things. So here's a few examples. Int count. So I'm saying that count is an integer. So it's a whole number. Positive or negative, doesn't matter. It's just a whole number. Same thing with numvals. Maybe an average should have a decimal component, so it would be a double. So double average. A char, say for the first initial, M for me. could be a char. So that's the declaration. This is saying, this is telling Java, this variable exists, it is an int, and its name is count. That's the idea of doing this declaration. So whenever you hear me talk about, oh, did you declare the variable, or how did you declare the variable, this is what I mean. There's another sort of step to this. You don't have to do it at the same time, but it's a good idea to do it at the same time or somewhere nearby where after you declare it. So before you can use the variable, you should give it a value. And I sort of have must and should here. For the most part, you are going to want to give it a value, but it's not a strict rule. It's not something that Java is going to enforce. So the sort of must here is my recommendation. The should is sort of the Java recommendation. Some languages, and sometimes even different compilers within the same language, will either just give you a random value or 0 if you don't initialize the variable. Typically, that's not good for your program. I had a situation where when I was in grad school that it took about a week for me to figure out that I was getting some strange results in a code I was working with because I forgot to initialize a variable. And so it was just giving me a random value and sending that in, and that was messing up the calculations I was doing. So a simple, small little error like that caused a week of heartache trying to figure out what was going on, because sometimes it would work, sometimes it didn't, and it was all because of a random value. So you should give a variable a value before you start using it. Generally, Eclipse and sort of Java in general will notice when you haven't initialized a variable and let you know. But you do want to be careful when using other languages. So let's talk about how you actually do this. How do you initialize? What's the syntax for that? So you can do it after the declaration. So previously, somewhere previous in our code, we've said int count, and then a semicolon. Somewhere later on in our code, further down in the lines that we have, we can say name equals, and then a value. So I could say count equals 0, for instance, and then, of course, a semicolon. That's one way to do it. That's assigning a variable or initializing the variable after the declaration. But we can actually do it at the same time as the declaration. So I do my type name, and then I just say equals value. So I can say int count equals 0, semicolon. So you can sort of put it in one line, which is very common, or you can sort of initialize it later on if you want to. So my recommendation, you want to do this. Typically, you do want to do something like this for every single variable that you create. So here's a few examples. So here's that count equals 0, semicolon. So presumably count and the next one, ultimate answer, was declared somewhere above this little snippet in my code. Whereas the next two, numvals and pi, those are being declared. So numvals is an int, and it's initialized to 10. Pi is a double, and it's initialized to 3.14 and a little bit of change. This example also shows something that I want to point out in terms of style. So every once in a while in my slides, I'll have a little style note. It's not something that you have to follow, but most places, most people sort of try to follow these rules when they write their code. When you go off to co-op, for example, in your sort of junior and senior year, or you get a job after you graduate, wherever you work will probably have their own sort of style that they prefer, so you definitely want to follow that. But as you're sort of programming in various classes, try to stick with a style that makes sense to you. So the style note here is that if your variable contains multiple words, so ultimate answer, or numvals, capitalize the first letter in each word except for the first one. So I have ultimate answer. This is known as camel case, and it's very common. Some languages, the standard style is what's called Pascal case, which has capitals for all of the words, including the first one, capital first letters. So it depends on what language you use, where you go for a job or co-op or whatever. But most of the time, the way that you're going to see me program is like this. So I'm not going to use underscores. I'll just have something like this, ultimate, and then a capital A answer. It makes it easier to read than if you just use all lowercase or all uppercase, but you don't have to worry about using underscores everywhere. So that's sort of one of the standard things. So again, you don't have to do this, but this is the way that you will see me doing it. So it's sort of a style note related to variable naming. Okay, so we're going to switch to Eclipse, and we're going to do a quick example. I have something in the code here that you haven't really seen before. This is the print, but it has a little something extra. So we're going to talk about that. But I just want to go in and create a variable, and then we'll print it out, and then we'll talk about it. So for the quick example, I already have just a blank file in Eclipse open, just a blank project. So if you remember how to do that, file new, Java project, you create the empty project, and then you right click in the project and say new class, and you give it a name. That will essentially get you to this point. So if I want to declare a variable like magic points, I would do something like this. So saying int magic points. Eclipse gives us a little squiggly underneath. This one's yellow. When you see a red squiggly, that means an error. That means your program's probably not going to run correctly. A yellow squiggly underneath is actually just a warning. And what it tells me, if you can't quite see, it says the value of the local variable magic points is not used. So it's just telling me, hey, you created this variable, but you're not using it. So in principle, I don't need the variable to run this program, even though it's the program doesn't really do anything at the moment. So I've declared it. Now I can do my initialization. So I could say magic points equals, say, 100. And that works fine. So that's our separate declaration and initialization. Or if I get rid of my initialization down here, I can say equals 100. So that's my initialization and declaration all in the same line. Now the other line in the example code on the slides, the little quick example code on the slides, is a print. And we saw how to do this last time. We did some printing with Hello World. PA0 was all about the initial Hello World stuff plus all of the submission. So I'm going to throw that in. So system out printf. And when it does the autocomplete for me, it has two parts. It has format and it has args. I'm going to use both of these parts. So in format, that's where I put my string. So I might say magic points equals, and then I'm going to use something special. I'm going to say %d. You've seen %n. I'm going to put one of those in as well. This is a new line. So we've seen %n. %d is something a little bit different. So after that, I'm going to close my quote. And then for the args, I'm going to put magic points. Then, of course, a semicolon. I'll save that. Now we don't have any warnings. We don't have any errors. So when I run this, it says magic points equals 100. It doesn't print the %d. So, of course, with our variables, our program wouldn't be too useful if we couldn't see what they were, if we couldn't print them out to the screen, especially if we don't have access to the code. Right? If we were running someone else's program, we'd probably want to know what certain variables were. So that's the idea here. We can print out our variables using some special syntax. So we go back to the slides. I have a few pop-ups here, declaring and initializing the variable. And then what happens next? We print it out with some special syntax. So system out printf can be used to print the current value of variables. Printf is useful for this because it has the formatted print options. So you can do things like print out only a certain number of values past the decimal place, for example, if I was printing a double. But we can't just put the name of the variable in quotes. So flip back to the code real quick. I can't just put, if I delete all the rest of this, I can't just put magic points. That doesn't work because it just literally prints magic points. So that's why we need those special characters, in this case, the %d. So when printf encounters one of those special characters, the %d, that's a conversion character. So printf knows there's going to be a list of variables after the quotes end. And it's going to fill in the special character with the value in the list. So here's that same line. It knows there's a %d. So after the comma, after the quote and the comma, it's going to take whatever variable's there, figure out what its value is, 100 in our case, and then substitute that in for %d. So this is an easy way to print out the values of your variables, and you'll use this in a lot of contexts. In homeworks, you'll be printing out results of calculations. When you're trying to figure out what's wrong with your program, why it's not working right, you'll probably throw in some prints to see, is my calculation working correctly? What's going wrong? What value is it actually getting because it's not correct? You'll throw in a print, for example. It is important to put that comma after the quotes. So you do need this comma because that's saying that, okay, now we're starting the list. If I had more than one %d, then I'm going to have magic points, comma, and then something else, comma, something else, and so on. So you use the comma to separate more than one variable if I have, for example, more than one %d. Okay, so let's do another, maybe a little bit more complicated example. So I've got x, y, and z, and just set to whatever values, it doesn't really matter, 1, 2, and 3. I want to know, what do we have to type to print out this line? 1 plus 2 equals 3. So let's go back to Eclipse, and I'm going to go to a completely blank file again. And I'll create my variables. So I'll have x equals 1, y equals 2, z equals 3. So I got my 3 variables. So let's think about what we want to print out. I'm going to throw in a comment. We talked briefly about comments in the last lecture. We'll talk a little bit more about them today. I want to say, let's see, I say we want to print 1, or we want to print 1 plus 2 equals 3. That's what we want to see. So we're going to start, I'm going to bring this frame down. So we're going to start with a system out printf. And I'm going to let it do the autocomplete for me. Remember, the format is the stuff that's in quotes. So anything in here, that's what we want to actually print out verbatim or put in conversion characters. So the first thing I want to print is a 1. That's going to be a variable. So I can put a %d because I'm going to use x in here. Then I can literally verbatim print out a plus. And then I want to print out the variable, the value that's stored in y. So I need another %d. And then I'm going to print out verbatim and equals, and then another %d. And we'll throw in a new line for good measure. Now we need to put in the args. The first conversion character we reach is going to be included from the first variable in the list. So that would be x. And then the second one would be y, and the third one would be z. I'll save that, and I'll run, and there's our print. So this idea of using multiple variables with multiple conversion characters, that's how we print out more complex things with variables that we've created. So hopefully this makes sense with the printing that we've seen before. Is there any questions on this so far? The printing, the declaring, the assigning, the initialization. Is there any questions on these pieces so far?
There are different ways to do like the printing of the variables, right?
Yeah, so we'll talk a little bit about print line in the near future as well. Specifically, when it comes to things like strings and stuff, that's sort of what happens when you use print line and potentially print. So the formatted print gives you a little bit more control over things like the number of decimal places you print after a double, for example. But yes, there are more ways that we can print out variables, and we will talk about some of those coming up, I think, in this lecture, and I think maybe a little bit in the next lecture. In the chat, I've got a couple of questions. So Paxton, what does the ARG stand for? Yeah, so when I do the autocomplete stuff for system out printf, and I just sort of press enter after I type printf, it has the format sort of piece, which again is the stuff for my strings. And then if you have any conversion characters, so any things like %ds or %f or a few others that we'll talk about later, that is the variable names that go here. So if I did %d, then in the arg's place, this is what's going to fill in the %d. And you can have as many of those as you need. So for this one up here, it was 3%ds, so we needed 3 things in the args. So the autocomplete just sort of fills that in for you and lets you know that, hey, you can put stuff here. If you're not printing any variables out, you can just get rid of it completely. So with printing no variables, with printing out no variables, just my hello, I don't need the args at all. So that's sort of the idea, just sort of a filler thing. Elijah, what does a %n stand for? Yeah, so that is new line. So it's kind of like a conversion character, but it just automatically gives you a brand new line afterwards. So if I were to run this, notice how we have 1, 2, 3. So that was from this first print. And then on the next line, we have a 1, hello. So this %n gave me a new line between my 1, 2, 3. And then I printed out 1, because that's what x represents. And then there was no new line here. So it printed out hello right after. So the %n will give us a new line. This is what I recommend for the homework. The homework is, the unit test can be a little bit tricky, and they can be a little bit picky when it comes to how you use new lines. So if you're using printf, use a %n to represent the new line. All right. Other questions? Do you have any other questions related to this? Okay. So let's look at back to the slides. So this also has sort of the solution for this on there. That's what you'll see in most of my slides. You'll see sort of a solution to whatever question that I'm asking, so that if you go back and look at these, then you will sort of see that available to you. So let's look at a few more common conversion characters. So for an integer, you always use %d. That can be a bit tricky to remember because we have a type called double. So you think %d would be for double, but that's not the case. It's for mostly historical reasons. Some of these variables, the very sort of beginning of sort of programming, were called like decimal. So it's a decimal number is an integer. So %d sort of came from that, and it's really stuck around for a long time. A double is %f. This stands for a floating point number. So if you want to print out a double, it's got to be %f. A character, if you want to print out just a single character, like an A or something, it's %c. And a Boolean is %b. We're going to talk more details about these later on, particularly with the double, because we can have a lot more control over how we print a double just by modifying this conversion character. But for now, these are the common ones for printing stuff out. So as a few examples, here's the creation of a few variables. So we have the declaration and the assignment happening on the same line. Then we have a couple of prints. So I'm going to flip into Eclipse, and I'll sort of show a couple of these, probably show like double and character, but there's a couple of examples here as well if you want to throw those in too. So back over in Eclipse. I'm going to get rid of the printing that I have here and just create a couple more variables. So let's create a double, and I'll just call this double average. I'll just call it AVG for average. And I'll say this is 3.5. And maybe I'll create a char, and I'll call it, I don't know, first initial. And I'll say this is M. So create a double, create a character, and then I'll show you how to print them out. So if I want to say something like, so here's my format and args, so I'll put my 2 quotes in and then start filling it in. So I might say something like first initial. It's a character. That's what I want to put here. So I'll put a %C, and then I'll say average. And then average is a double, so I need a %F. And then I'm going to throw in a new line in there as well. So in the args, I'm going to put first initial and AVG for average. So when I print this out, when I run the program, here's my M from the %C, which got filled in by the first variable in the list because it was the first conversion character. Then I have my 3.5. Notice it adds a bunch of zeros in here. Again, there's ways that we can modify what it actually shows, but we'll talk about that later on. So we have average 3.5. So there's my %F printing out average, and it prints out my 3.5 with a bunch of zeros. So that's the idea of using these other conversion characters. I can't use %D, for example, here. So if I change %F to %D, it doesn't look like there's any issues, but when I run, I get a bunch of red text. So if you see something sort of weird happen during a print, so here you see that it printed out a little bit of it, but didn't get that last number in, it actually tells you what goes wrong. It says D, which is my %D up here, is not meant for double. So it gives you some information about what's going on, but this is sort of a very common thing to have an issue with. Just accidentally using the wrong conversion character, particularly between doubles and floats, or doubles and ints. So we do need a %F here. So the next part of what I want to talk, so that's pretty much all sort of variable stuff. The next part of what I want to talk about is getting some input. So we can print to the command line. So what about reading from it? We want user input. In video games you play, you use WASD, you use arrow keys. At the minimum, you use your mouse to do stuff. So how do we read from the command line? If someone wants to type something in, say type a value or enter in some arrow key stuff, how do we do that? We've seen for printing, it was system.out. System.out dot and then printf or println or just print. We saw that those 3 last time. Java does not have something easy like that for reading in from the command line. There is no sort of system.in dot read a double or read int or something like that. So instead, we use a scanner object. If you've done sort of object-oriented programming in the past, you sort of probably understand what an object is. For now, if you don't sort of know what I mean by object in this case, then just sort of take the syntax as sort of standard syntax for now, and later on in the semester, we will get back to it. So we'll create a scanner object that actually reads input and ensures that whatever was typed in matches what you want. So that's the idea of the scanner thing. So you're going to be using this a lot. You'll be using a scanner for pretty much every single assignment, including the one that I'm going to assign on Thursday. The syntax is a little strange at first, especially if you've never done any object-oriented programming before. So we're going to learn about what all of the stuff means, but for now, just use it as is. If you're not familiar with sort of object-oriented programming stuff. So the first thing we do, and this usually happens somewhere near the beginning of your program, we need to declare and initialize the scanner object. It's kind of like a variable. The stuff that we just talked about. We have a type, it's a scanner. Just like we had types, ints, and doubles, and all that. So the type is a scanner. We have a name, it follows all the same naming rules that we talked about, so input in this case. And we have the initialization. Now the initialization looks very different. Notice there is a system.in, but it's used as part of the scanner. So we have to use this keyword, this new to us keyword called new scanner. So we repeat the type again, and then we put this system.in and parentheses. For those who have done OOP stuff before, we're just calling the scanner constructor and sending in system.in. But if you haven't done OOP things like this before, just think of it like creating a new variable. It just has something special for the initialization and a different type that is called scanner rather than ints or doubles or any of that. Then we can read in a variable. So let's say the variable here, let's say this is an int. We just say the name, whatever I named my scanner. So the name of my scanner dot next int, and then an open close parenthesis. So this will read us the next int that's typed into the console and store it in variable. If we wanted to read a double, let's say variable here was a double instead of an int, then we would have to use next double. So it has to be reading in the right type. We got to use the right type here for our variable, and then the user can type whatever they want to. So that's the idea. Create a scanner variable with whatever name you want using this syntax. Then we use that name with a dot and then a particular method. So this is the next int method to read in an integer, or the next double method to read in a double, or something that's like 3.5, for instance. Okay, so let's actually do this. This example here, I may not follow exactly what is here, but I'll sort of try to go through it. I have some pop-ups here as well, so we'll talk about those once I code them up. But as I'm going over it, I will mention a couple of those things. The pop-ups are mainly meant for if you come back to the lecture slides in the future. So go over to Eclipse. I'm going to completely delete everything that we have here because I don't need it for now. The first thing that you have to do, if you want to use scanner, at the very top of the file, so above main and above the class, we need to say import Java util scanner. So this is telling Java that, hey, we want to use the scanner. It has a yellow squiggly line because it says you've never used scanner. So it says the import Java util scanner is never used. Okay, I haven't used it yet. But this tells us that we want to use the Java utility called scanner. So take this for granted and just make sure to put it in. So just leave it in there, put it in pretty much all the code that you're going to use. Don't worry about too much about exactly what it's doing. That's something that we'll get to later on, and probably a bit more in CS2 as well. Now I can use the scanner. Now Java knows, hey, he wants to use the scanner. So now I can say scanner, and I could give it a name. Typically, the names that you sort of call scanner are something like input. It's sort of a standard name for a scanner. There are other names that folks tend to use as well.
You're not dating them. I just wouldn't want to ruin something so special.
So we'll do the type, name, initialization. So I need to do the new scanner, and then I put in system.n and a semicolon. And that's it. So now I have a scanner that I can use to read stuff in. Typically, again, you'll put this near the beginning of your program. So right now, we have main, and then we have the creation of the scanner. And then I can use it anytime I need to in my program, anytime between the open curly bracket and the close curly bracket for main. Let's create a few variables. So I'm going to create a couple of ints. I'm going to create magic points, and maybe I'll create hit points. And I'm not going to assign a value to hit points yet. I'm not going to do an initialization. I did it for magic points. So here we have initial value is 100. This one has no initial value, at least not yet. So I'm going to do a print. Say system out printf. I'm not going to print out any variables here. I'm just going to say enter value for hit points. Something like that. So I didn't print out any variables, so I didn't need that args piece. I just printed out a string, just exactly verbatim, entered value for hit points. I did put a space here. We'll see why in just a second. And I don't have a new line. Right after this print, I'm going to use my scanner. So I'm going to say input dot next int. Now this doesn't do anything by itself. It will wait for you to sort of type something in, but it's not going to save the value. So I need to say hit points equals input dot next int. So this will grab the value that I type in and save it into hit points. That's the idea of this line. And then let's print it out. So I'll do another printf, and I'll say number of hit points, and I'll use a %d since it's an int, and a %n for a new line. And I'll close my quote. And then for the args, I have 1%d, so I need to put a value here. This will be hit points, the hit points variable. So when I run the program, say enter value for hit points. Notice where my cursor is. It's one space over after the colon here. And I can type, say, 50. I press enter, and there we go. Number of hit points, 50. So using the scanner it's not too complicated. It's really just this line to actually use it after you've created it at the beginning of your program. So hit points equals input dot next int. One of the things you might notice about this program is that input has a yellow squiggly. I do use it, so it's not saying that I'm not using input like it is for magic points. Magic points says the local variable, magic points is not used because I didn't print it out or anything like that. But input is used. So what is a squiggly? So if it's a little bit tough to see, it says resource leak, input is never closed. When you open a scanner, it's sort of always going to be there. And the typical thing to do is at the end of your program or whenever you're done using it, you do something like this, input dot close. And now the yellow squiggly here went away. You don't have to do this. It's not going to break your code. The stuff that we write for our assignments, it's not going to cause any problems. But if you want to get rid of the sort of issue that it shows, the warning that it shows with your scanner name, then at some point after you're done using the scanner, you should put input.close. We'll see later on other ways to do this sort of close thing without actually having to type any extra code. But for now, this is one way that you can close out your scanner. Again, it's not required. I'm not going to like take off points or something in an assignment if you don't close your scanner, because it's not really relevant for this class to know that you sort of have to do this and why it's important and all that kind of stuff. So if you don't want to do it, that's perfectly fine. If you just want to forget about it. Otherwise, if you want to get rid of the warning, then you can throw in an input.close. So when I leave it out and I run, everything is perfectly fine. And of course, I can type in whatever value I want to here. So as far as using the scanner sort of initially, is there any questions? All right, so back over to our slides. I got a few pop-ups here. It just sort of tells what each one of these pieces does. So if you don't want to go back and watch the recording in the future, you just want to look at the slides, it does have the pop-ups about it. So telling Java we're going to use scanner and creating the scanner and then using the scanner to read an int and then noticing things like hit points wasn't initialized. So basically the stuff that I talked about going through the example live. It does have a little bit of extra printing. So number of magic points, it prints that out as well. But we've seen that. There's a few notes that I want to mention related to the scanner. All of the inputs are automatically separated by white space. So if you want to read in more than one thing, you can put a enter between them. So a new line, you can put spaces, tabs, whatever you want to. It will treat every single value that you type in as a separate value if there's white space between it. So if you want to read more than one thing, you can do that. You need multiple next int calls or next double calls, but it's just spaces or tabs or new lines between them. So multiple values can be separated on a single line by using white space. The program will pause execution, so it will just sit there and appear to do nothing while it's waiting for a non-white space value. So that is something to consider as well. And what I mean by non-white space value is if I run this program and I press enter a few times, it doesn't continue on. Enter is considered a white space value. So right now it looks like, wow, is my program like frozen or something? What's going on? It's just waiting for a value. It's sitting right here at this line. You can always tell if your program is still running by looking at the little red box over here. If the little red box is highlighted, so if it is red, then your program's currently running. And pressing the red box, the little stop button, will terminate your program. So that is something worth remembering as well. Because if it looks like your program's not doing anything, look and see if it's actually running over at the little red square, the little red stop button. Okay. This is an easy one to forget. You do have to have this Java util scanner. If you don't, if you miss that, so I'm going to go up to the top, I'm going to delete that line. Eclipse will give you an error. So it'll be a red squiggly under the name scanner. The nice thing about Eclipse, though, is it can help you figure out how to fix it. So if you hover your mouse over, it says scanner cannot be resolved to a type. Okay, that's the error that it comes up with. But the first few fixes available, they all say import scanner. The one you want is the one that has Java util in parentheses. So if I click on that, if I click on import scanner Java util, it will automatically put this in for me. So in principle, you don't actually have to remember to put it in. You just start using scanner like you normally would, and then hover over it and say import scanner Java util. So that's a sort of another way to handle it rather than having to remember where what this line actually is. So there's a few sort of niceties when it comes to things like Eclipse and other IDEs. All right, comments. We've used them a few times. You've sort of seen me sort of put them in occasionally. In any source code, you can, and you will, in our assignments, include comments. They're just meant to explain in sort of plain English what's happening in the sort of region of code. There's two types of comments in Java. There's single line comments that start with a //. So you've seen those. I've been using those to sort of do sort of one line thing. Everything after the / until the end of the line is just ignored. So Java does not care about whatever you type in after that. There's block comments as well. So you can start with a /* and it would end with a */. Everything in between is ignored by the compiler. So it doesn't matter how many lines are in between them, it's all ignored. We also saw in PA0 the other type of comment, the javadoc comment. So again, this is a line comment. So anything from the // to the end of the line is ignored. So that's why it's this sort of gray color. The block comment is something like this. Now, Eclipse will automatically sort of start putting stuff in here for you like this. You don't have to have these stars here, but this just makes /* and it puts the */ for the end. And anything I type in between is all going to be commented. And then, of course, we had the /*, which specifically makes a javadoc comment and will do some automatic stuff for you. So, for example, if I put something right here above main and I do a /*, it automatically puts in a few things for me. So the javadoc comments, you'll want to put wherever you see the to-dos. So the to-do in a homework for above main or above the class and above the main method here, you're going to want to put java.comments. In the rest of your code, you can put block comments if you want to, or you can put line comments describing things. So I'm going to show you an example of sort of how I would comment something for an example code. And on this Friday's lab, we will look a little more at commenting one of the actual assignments. The lab this week will be dealing with PA1, so we'll actually do part of PA1 in the lab altogether. All right, so here's an example. This is basically that code that we just wrote. So the scanner, the printing stuff out, whatever. It's basically all that stuff. This is this type of thing that I would expect in your homework. So you don't have to comment every line. If you have a region, so in this case, it's creating hit points, asking for the number of hit points, and reading in the value, you can just put one comment for that. Initialize the number of hit points to whatever the user types in. That explains what the next few lines actually do. That's the kind of thing that I'm looking for. Right here, very, very simple. It's printing out a couple of lines, and the comment is print results. That works. But I do want to see comments like this throughout your code. Think of it kind of as a commentary. One of the big things when it comes to comments is that after you write some code, particularly if it's some complicated code, 6 months from now, you're not going to remember anything that you did. And I come across this all the time. I come back to code after usually just a few weeks, and I'm like, wait, how does this work again? So if I don't have comments in there explaining things, at least in some minimal way, it just takes longer for me to grasp what's actually happening. I have to sort of figure it out again based on the code, rather than a nice comment telling me, hey, this uses some particular algorithm that I found from this website. Like, that is super useful, because then I don't have to figure out exactly what it does. I can go to the website again, or I can be like, oh yeah, that's the A-star algorithm. So that's the idea of comments like this. So I want you to get into that habit. A lot of places, when they have developers work on code, there are more comments than there are actual lines of executed code. I have a couple friends that work at MathWorks, for instance. If you've used MATLAB in the past, MathWorks is the maker of that. And the developers there, they literally write more comments than they write actual code, because the developers have to be able to explain to the documentation writers, the ones who write the help stuff online, they have to be able to explain, what does this do and how does it work? So that the writers that write the documentation can actually write good documentation for what the code that they wrote actually does. So comments are very important for when you go out and sort of work in the real world. So I do want you to get into this habit. For the first couple of assignments, I'll be sort of relatively lenient, and I'll give you commentary on sort of, do the comments look good? Where would I add stuff? Things like that. But as we get later in the semester, I will take off points for commenting related issues. So comment your code as much as possible. It does not have to be every line. That's you don't have to do every line, but sort of regions of code that sort of do something specific. Again, like printing results, for example. Okay, so we have sort of 20-ish minutes left. I just want to do, this isn't really sort of mid-lecture, but I just want to do a quick sort of overview of the things that we talked about, because we definitely sort of have gone over a few roughly separate sort of topics. So Java programs are executed one statement at a time. So it's that sequential execution, starting with main and then going down from there. So that's what we've seen in these examples. The concept of parallel programming, which is a class that you'll take as a junior during the summer, it totally destroys that idea. I usually teach 3 sections of that in the summertime, and it is quite a fun class, but also quite a rigorous class. So basically, this idea totally destroyed in that parallel class. System.out.printf or printline, which we'll come back to here in just a second, can be used to print values to the screen. So you can use printline to do that, and I'll show you either later today or potentially next time. Use double quotes to print your sort of literal words, your sort of verbatim words, but you don't use the quotes to print actual variables. You can use printf and those conversion characters we talked about. And then, of course, scanner is used to read things from the user, and of course, always include comments to explain what your code is doing. So that's sort of the stuff that we sort of just talked about. All right, so there's a few sort of extra things that I want to get done here in the last sort of 20 minutes-ish. We'll see sort of how far we get. We may not get totally to the end. I don't know exactly how much I have left. A quick sort of memory review. Data values, your variables, they're stored in main memory. So they use up some of your RAM. And they're stored with bits. They're stored with ones and zeros. 8 bits make up 1 byte. So 1 byte typically can contain sort of integer values between 0 and 255. So the program needs to know the type. We have to put it in there. We got to say it's an int or it's a double or whatever it might be. So it uses the type to tell Java 2 things: how much memory is required and how to interpret that data. So that was the question that I asked earlier. Is it a number? Is it a Boolean? Is it a character? And that interpretation then, of course, informs Java how to deal with it. How do you deal with taking an int and storing it in a value that's a double, for instance? So it tells you how to deal with it. So this is sort of these are the 2 main things. Memory is an interesting one. And we're going to talk a little bit about the memory sort of requirements of some of these variables. And then sort of the interpretation is stuff that we'll sort of go through with examples and you'll sort of be working with for most of the rest of the semester. How do these things get interpreted? So I want to give some more details on these types that we talked about earlier. So an int, it's an integer, it's a whole number. Here's a few examples. They can be positive, they can be negative. There is a range though. And this is related to the memory. An int is 4 bytes. So there's 8 bits in 1 byte. So this is a 32-bit number. For an integer, that goes between this negative 2 billion and change to positive 2 billion and change. The actual values here, negative 2 to the 31 to 2 to the 31 minus 1. That might seem a little weird. Okay, it's 32 bits, but that's almost the same as 31, but it's not. So why is it 31? And what's up with the minus 1 here? So if we look at the range, this goes to the last 2 digits here, 48. This one is 47. So we'll talk about that here in just a second. We also have doubles. Doubles are twice the amount of memory, 8 bytes. So that can have decimal points. It's essentially scientific notation. And when it comes down to it, any sort of floating point number like a double is actually scientific notation for base 2, but that sort of gets a little bit deeper into what the hardware does. We essentially have 16 digits of precision. So you can sort of trust 16-ish places after the decimal. But scientific notation-wise, we can go from 10 to the negative 308 to 10 to the 308. So we can have like 1.325, whatever, all the way out to 16 decimals, times 10 to the negative 308 to 308. That's sort of what that encompasses. So we don't get 308 decimal points of precision. We only get about 16 of those. But scientific notation-wise, we can go to sort of estimates or sort of rounding of very large numbers. And they can be positive or negative. When it comes to the int, you may have seen these numbers before. If you played some mobile games that have a sort of a high score system, you may have seen this exact number before. Most likely, somebody figured out that, it's an int that stores the high score. And with a little bit of manipulation, maybe a little bit of sort of extra program, I can manipulate the memory where the score is stored in my program and just change it so it's the largest number possible for an int. So you may have seen values like this before. The 31 is because of the positive or negative. So it's 32 bits total, 32 ones and zeros represent this. But one of those ones and zeros represents the sign. Is it negative or is it positive? So that's why we only have 31 actual values that we can use. The minus 1 comes in because 0 is also one of these values, because 2 to the 0 is 1. So there's no place for 0 here if we just use this sort of 2 to the 31 values. So we keep 0 on the positive end. So that's why we only go to 47 here, where it's negative goes to 48. So that's sort of the idea. That's where these come from. They're not sort of randomly sort of created, and that's how large the value is. It's all related to the amount of memory. Same thing here, although I don't have a good explanation for the negative 308 to 308. I'm not sure why that's the value. I'd have to look it up. But it's sort of a similar thing. It's restricted in terms of memory. So that's sort of related to that. So you may have seen the range of an integer that uses only 2 bytes of memory. So this is an int that's 4 bytes. There are ints that use 2 bytes. So that would be negative 2 to the 15 to positive 2 to the 15 minus 1, which is like 35,535, I think. So you may have seen that number potentially as a high score as well in a game, because that's the maximum size, the maximum positive number for a 2-byte integer, for example. So this might seem a little sort of like, again, spending tons of time on this, whatever. But when it comes to thinking about the variables that you need, if I need a number that's greater than 2,147,000,000 and change, then I need to do something different. I can't use an int because this is the maximum value. So thinking about some of these types and sort of their restrictions can be very important depending on what your program is meant to do. This is why, as well, if you've played like Minecraft or something, there is a maximum size to the world, because depending on what values they use for the potential size in X and Y for the actual world, you wouldn't be able to go past this many blocks, for instance, in one direction. So there's some sort of interesting consequences there as well. There is a precision that is better than double. There's more than double. It's a quad. You get 16. Quad uses 16 bytes of memory. Typically means you get about 30-ish decimal points of precision. So there are sort of larger memory footprints, things like doubles and ints. You can actually go to 8-byte ints as well, for instance. All right, so chars, they're just a single character. They are always in single quotes, always. You never put a char in double quotes. These typically take 2 bytes of memory, maybe 1 byte, depending on the language. There's also strings. Strings are a little bit different. They're a sequence of characters or symbols. You always put these in double quotes. So when we print something out using printf, we use double quotes. So that is a string, sort of technically a string. So strings are different than the basic types. The other types we talked about, int, double, char, boolean, that sort of stuff, those are called primitive types. They're sort of the simplest types that we have to represent things like numbers and characters. Strings in Java are actually a class. They're technically objects, kind of like scanner, but they're meant to sort of represent sequences of characters. So we're going to talk a lot more about classes later on in the semester. For now, I just want you to know that there's extra things that you can do with a string. So for example, there's a length method that we can do to tell you how long a string is. So we'll look at more of this stuff later on, but just know that a string, something in double quotes, is a little bit more complex than a regular character or an int or a double or something like that. So here's just a quick example of that. You can create a string as a variable. You just use a capital S string. So this one here, to boldly go. You can print out a string by using %s. And then if you want to know how long the string is, for example, notice I use a %d, but I say my message, my string, dot length. So kind of like scanner. Scanner, we'd say input dot next int. Well, for a string, I can say the name of my string, message or MSG, dot, and there's a length that I can use. So there's some similarities between things like scanner and strings in terms of sort of how they operate. But we can use a conversion character to print stuff out. So the conversion character %s. And we'll see more with strings a bit later on. I just wanted to give you sort of the basic overview of sort of a string example and sort of how it works. So there's a couple pop-ups here. %s is the conversion character, and length tells me in an integer how long that string actually is, because it's a collection of individual characters. There's also the Boolean data type that is just true or false. It uses at least 1 byte of memory. Remember, a byte is 8 bits. And there's only 2 possible values for a Boolean, true or false. So I suppose the sort of question is, well, why can't I just use 1 bit? Why do I got to use 8 bits? Why do I have to use a whole byte? The main answer to this is really related to some of the hardware stuff. Typically, you can't access individual bits. You have to access them in terms of bytes. Sometimes, depending on the system, you can only access 1 byte at a time at smallest, or it might be even 2 bytes. The smallest thing you can access actually the 2 bytes on some hardware as well. So Boolean, just always think of it as 1 byte, but it's really actually only using 1 bit. It's sort of wasting 7 bits. There's not really much we can do about that. When it comes to working with different types and how they work together, in general, you can't assign a value of one type to a variable of another type. We're going to break this rule, of course, but because there are some exceptions and there's ways to force a conversion. But it's always worth checking to make sure that it's going to give you what you want. So as a rule of thumb, try not to mix types except when it's necessary, and always sort of check when you do. So what do I mean by that? If I have an int and I have a double, so this right-hand side, Java sees this as a double because it has a decimal point and some numbers after it. But I'm trying to assign it to an int. This will give me an error. So back in Eclipse, let me get rid of all the stuff I have here. And I'm going to say int sum equals 1.99. So if I hover over this, it says type mismatch. Cannot convert from double to int. So that's what I mean by mixing types. I have a double on the right-hand side of the equals, and I have an int on the left-hand side. That causes a problem. Eclipse does not like that. Java does not like that. If we could do this, then you could imagine that, well, it's either going to cut the decimal place off, so we'll get 1, or I don't know, maybe it would round, so we get 2. So rather than sort of have this potential ambiguity or a rule that solves the problem, it just says, I can't do it. You got to figure something else out. You got to do this differently. So that's why it sort of errors out for us, so that we have to figure it out and the compiler doesn't just sort of magically figure it out for us. But we can assign an int to a double. So if I flip this around, so if I say double average, for example, equals 2, Eclipse and Java sees this as an int. 2 is an int. But there's no problem here. I can assign an int to a double. So you can go one way, but not the other. I can go int to double, but not double to int. There's a very specific reason for that, something that we won't really get to until much later, potentially even, depending on exactly how far we get with everything, potentially even in CS2 as to why this actually happens and sort of what this means in terms of things like object-oriented programming and stuff like that. It has sort of links to all of that stuff. But for now, think about it like that. You can go one direction, but not the other when it comes to ints and doubles. Strings and characters, they don't mix at all. So if I say character or char letter, so just some letter, and I try to set that equal to a string with double quotes, it's not going to work. It's never going to work. Same thing with a string. If I create a string called name and I try to assign it a character with single quotes, it's not going to work. It's never going to work. So strings and characters, they don't mix at all. Other numbers, they do, but sometimes they only go one direction, int to double rather than the other, double to int. So if you notice something like that, something weird like this, where you're like, I don't understand why this doesn't work, just hover over, and if it says type mismatch, then you know that it's one of those directions that it can't go. One of the interesting ones that may not make sense at first is characters and integers, they're interchangeable. That might sound kind of weird. Char letter equals 33. This is an int. But if I printed out the char, it would print out an exclamation point. Just like an integer as a character A prints out 65, or capital A prints out 65. This is all through the ASCII table, which I'll probably sort of do a little bit more with once we start doing some character things with our actual like homeworks. But this ASCII table will show you what the letter is and what its decimal value is. So a capital A is 65 in an int. So characters and letters are actually interchangeable, which is actually kind of cool. All right, so we got about 5 minutes left, so I'll just do a little bit more. Mathematical operators. Generally, you use these with your numeric types. Not always, but generally you use them with numeric types like int and double. We've got your standard addition, subtraction, multiplication, division. They're used just like this. So I have some value that I'm going to save to, here, part 1 plus part 2, or total minus used, or mass times acceleration. So it's being saved, in this case, into force. Total divided by num items gives me item weight, for instance. So this is how you use addition and subtraction in multiplication, division in your code. These are the 4 sort of standard operations. Depending on the type of the things on the right-hand side of the equals, that determines what you're going to get on the left-hand side. So when both operands, so example part 1 and part 2, when they're both int, the result is an int. So if part 1 and part 2 are both ints, then the result that it's going to try to save will be an int. If one or both is a double, then the result is a double. So if part 1 was an int, part 2 was a double, then the whole result is a double. So this is something that we're gonna come back to, and we'll do some examples with, and I'll sort of show you what happens if you sort of make a mistake, particularly with division. Division tends to be a complicated one. String-wise, you can use pluses with strings. So if I had something like full, I wanted a full name, and I had a string that was the first name and a string that was the last name, the plus sign lets me do a concatenation. So it doesn't mean sort of addition, like you're adding 2 strings in some numerical way. It just means you're slamming them together. So it's going to take the first name, slam it into the space, and the last name, slam it onto the other end, and I will get first space last. So that's sort of the idea of a concatenation, and potentially we'll use some of that in the future as well. You can also combine other types into a string, and this is one way that you can use the print line function to actually print variables out. And so we'll probably look at that next time. So something like this, I can take a string and add an integer and add a character, and that will combine it all into one string using this concatenation. So there's some sort of interesting stuff with that as well that we'll sort of get back to and sort of look at in more detail later on. So we'll probably stop here. Let me I just had a few extra sort of assignment statement stuff that we can do next time. So more strings and expressions next time. In the lab, we're going to talk about PA1 and JavaDoc, specifically the JavaDoc from PA0. For PA1 in the lab, that'll be assigned on Thursday. We will go over part A and basically do part A together in the lab. And then the only thing that'll be left for you to do is part B. As you may guess, part B is the harder part. But we will do part A together of PA1 in the lab. So next time we'll sort of keep going from where we left off today and do more sort of string stuff and expression stuff with some more exercises. So Dan wasn't here with us today, but on Thursday he'll be around, and we will do some exercises where we'll break off into breakout rooms and stuff like that. I did throw the grading rubric in as well. So assignments themselves are just out of 5 points. Your score is going to be located in your sort of general repository stuff. So I will point these things out once I grade the first thing, the PA0. There usually will be a file, grade.txt, that sort of tells you sort of what happened, gives you some results of unit tests, that sort of thing. The breakdown looks like this. So the unit tests, the actual tests that you run, are worth 3 of the 5 points. Comments are worth 1 point. Style is worth 1 point. Style usually is just sort of a gimme, but if you do things like you don't use things like indentation correctly, or you don't follow what the directions say. Let's say you only do part of what the directions say, or you sort of leave out stuff, you probably lose a style point. Comments, if you have the java.comments and comments in your code talking about the individual sections, then you'll get the full score for this. And we will talk about this with PA1 on Friday as well, so to show you how I would comment the first part, PA1A. So I will break this slide out and actually put it on Blackboard itself, so that you can, if you ever want to see what the breakdown is in the future, you can head back over to it and see it from there. So that is it. My office hours are Tuesday, Thursday. So basically right after class, I'll probably go grab a drink, but I'm going to go into the office hour channel. So if you want to drop in, if you're having issues with PA0, I can either manually do some stuff for you to give you a repo, or we can check and see if you have that repo already and it just wasn't obvious that it had worked. If it sort of looked like it was failing, but it actually created it, we can do that as well. So you can definitely drop in if you have time. Otherwise, I will see you guys on Thursday, and I will be in the office hour chat in the office hour Zoom in just a few minutes.
Thank you.
Thank
Yeah.
you.
Thank you.
Thank you.
Thank you.
Professor?
Yep.
I think I emailed you this weekend. I was asking about PA0.
Sure.
And so is it fine if I share my screen?
Yeah, let me